Okay, so we've hit the hour mark, so let's get started. My name is Victor Palacios. I'm a data scientist at KNIME, and today we're going to be presenting on PDF text extraction using different tools like Regex and Python within KNIME. To be more specific, we will learn about text and image-based PDF analysis because each type of PDF requires a different method in order to extract the information from it. We'll also learn a little bit about patterns and how do we extract patterns using regex. And finally, we'll parse a unique language. In this case, we'll parse Japanese, but you can actually use the script that I will share with you to parse other languages as well with a Python integration. So let's get started. So first, it's important to know what kind of PDF you're dealing with. You could be dealing with first a text-based PDF. In a text-based PDF, I can actually click on anything. I can drag and drop, I can copy and paste, and you can usually tell when you're looking at a text-based PDF. On the other hand, you might have an image-based PDF in which you cannot copy anything, you cannot take from it. So this process for extracting text from a text-based PDF versus an image-based PDF is a little different. So for the text-based PDF extraction, we have two different nodes that you can use, and they each offer some different functionality. I'll start with the Tika Parser. The Tika Parser node is allowing us to extract the text, but it will keep the formatting, which we can then later exploit in order to get text that we need. So for instance, whenever you have a return or a new line, you might be able to use that in order to figure out which text corresponds to which section that you're trying to extract from. For instance, here we can see the output of the Tika Parser, and you notice that there are spaces, that there are new lines coming here and here and here. Every time you see a new line entered, that can be something that we can use in order to then later on extract certain parts of the text. And the Tika Parser is very versatile. It allows you to extract not only from PDFs, but from other sources as well. When we right-click the Tika Parser, we are given a series of options to choose from. This is the dialog. And there are many options to choose from. So which are necessary in order to go from a text-based PDF to the text itself? So for this, there are three options that we need to specify for sure. We need to say where the data is located, so the folder in which your PDFs are housed. You will also need to specify the type that you are going to extract from, for instance, a PDF or AC, etc. And I like to use this filter line here. You can type in PDF, and then you can move PDF to this side so that it only parses your PDFs. And finally, a PDF is actually a quite complex type of data, and it contains various metadata within it. For instance, you can see comments, the author, what year this was made in, and of course the content, which is the actual text that you want to extract typically. Down near the bottom where it says extract embedded files to a directory, etc., this part here is typically for images, and so you might use this for image processing later. And we also have lots of examples for how to use the Tika Parser on the KNIME Hub. And on the KNIME Hub, you can see various ways that people use different nodes and how they create different workflows. And of course, download everything for free because KNIME is open source and free software. Now, the other way that we can extract text from PDFs is by a PDF parser node. Now, the PDF parser node is a little different from the Tika Parser. First, the PDF parser, once you get from the PDF to the text, you will notice that the formatting has been removed. This might be useful for you depending on what kind of case you're dealing with. As well, the type that the PDF parser will give you is a document type. The Tika Parser, on the other hand, will give you a string type. So if you need directly to deal with a string, maybe the Tika Parser might be better for you. But in the case that you are doing more natural language processing or other text processing downstream of your workflow, then you might require the document type. So this may be useful for you. And we notice that the output for the PDF parser looks like a file path. But actually, the document type, very much like the PDF, has various kinds of information within it, and we can extract the information that we need from it. Now, when I right-click the PDF parser, I'll get a dialog box, and this box is much simpler than the Tika Parser because I only need to specify the data location. So where are these PDFs? What folder are they in? And then here you can leave these settings as is. So this one is a little bit easier to use. Now, once we've extracted the PDF data, we then need to say what data from the PDF we would like. And this is the document data extractor's job. This node will extract the text from the document or the author or any other kind of metadata that you like. So we can see here the output is very different than the output we saw earlier for the Tika Parser, right? We don't see any new lines. We just see a continuous string. This is because the formatting has been removed. When we right-click on the document data extractor, we can see various kinds of options to choose from. And this is what kind of data we want to extract. And up here, you must specify the document column. So if you have different documents within your table, you must specify the one that you would like to extract from. And for this, for the purposes of the presentation today, let's extract the text. Although you can notice we can do other things like extract abstracts or author, etc. Now, the Tika Parser versus the PDF parser, let's kind of look at the differences now that we've discussed these two nodes. Like, as we mentioned before, the Tika Parser is allowing us to read multiple types of files, not just PDFs, so it's more versatile in that way. As well, the output will be a string type versus the PDF's document type. And the formatting is going to be kept in the Tika Parser, but lost in the PDF parser. This can be on purpose if you need to, for instance, remove it, but you don't want to do it yourself, then maybe the PDF parser would be better. So let's talk a little bit about that. Which one do I choose? When do I choose them? For the Tika Parser node, use it when you need to keep the formatting, and use it when you have multiple sources coming in, not just PDFs. For the PDF parser node, use it when you don't want that formatting there for some reason. You need to remove it. And you might need the document type in order to go ahead and do more natural language processing or text pre-processing tasks. Okay, so now we know a little bit more about text-based PDF extraction, and we know that there are two nodes for it. Now we want to cover the opposite task, which is the image-based PDF extraction. To do this, we'll use the test4j node, which performs optical character recognition, usually known as OCR. And we'll talk about OCR in the next slide as well. Now, the test4j node only works on Windows at the moment, but don't worry, I will show you a way to extract from image-based PDFs using a Python integration later on. So if you use the test4j node, you must input an image, and this can come from the image reader, for instance, or it can come from the Tika Parser's second port. Remember earlier how we talked about how the Tika Parser can also extract images. So you might also connect those to the test4j node as well. The test4j node will then perform optical character recognition and make its best guess as to what text is contained in your image. And there are various examples for how to use the test4j node on the KNIME Hub. And these slides will be available to you afterwards, as well as the video for this. So how does OCR work? So OCR scans an image for light and dark areas. And this is going to be important in order to understand why we're getting really good output with some of our PDFs, but bad output with others. And so once it's scanned, finding these regions of dark and light, it then says that dark areas are going to be the letters. And so it will focus its attention there. And of course, the light areas must be the background. So maximum differentiation between the light and dark areas is going to help improve your OCRing. And the OCR engine can operate on character level or word level or even context level, depending on how sophisticated that engine is. Remember that a lot of the OCR engines that are out there are free. And so we will be held to the limitations of the freeware that we're using. And so for here, for instance, when we're looking at the word optical, we might first begin by scanning the O, and then the P, and then the T, etc. And many OCR engines nowadays will do a second pass. So the first pass was to look through it. And the second pass might be to, for instance, check the word itself and say, you know what, you identified character, I think, but you said that this is an O instead of an A. I think that's wrong. And so you can see there's some self-correction that can go on as well within the OCR engines. Even more sophisticated will run on a context where they'll look at an entity or a sentence and say, hey, I think you wanted to say optical character recognition, but over here, this O was recognized as an A. Let's change it to an O again. And then it will give you an even better output. Now for the image quality and structure, these really determine your output. And that's why we talked a little bit about how OCR works on a high level. So let's look at some examples for really good input and some bad input. Now, really good input will have maximum differentiation between the background and the text. So typically this is a white and a black color scheme. So you see here, this is our input, and it has, of course, that white background, and the text is black. Then you see the KNIME output, and it's over 90% accurate, which is fantastic. In most PDF text extraction pipelines, we typically aim for something like 80 to 90% accuracy because we know it's harder to get higher than that. Now, let's look at the opposite case. We now have low quality image, and it has poor differentiation between the background and the target text. Not only that, but it's tabular. And so you can imagine that a table, which is an image, which is being OCR'd, is going to give you a lot of problems. And this is typically one thing that we see a lot, even nowadays with paid software, that this task of converting a table, which is an image, into actual text is quite difficult. And so you can see here the results are very poor. And we have to consider, okay, why is that? Well, I have black text and I also have white text. Not only that, but I don't have very high differentiation. I have shades of gray, I have a darker gray on top, and I have these lines running through it. And the lines might be recognized as something else or interfering with how the OCRing is working. So that's why we might experience this kind of output. And for those cases, I would say try to go back to the source or do some pre-processing on your image in order to maximize the differentiation. And there's actually a really nice forum discussion on this, which you can check out later by clicking on these links in the slide. So let's say that you were able to extract either from your text-based PDF or your image-based PDF. Now you think to yourself, okay, what do I do? And I've found some very common tasks on the KNIME forum where people go and ask questions about PDFs, Regex, and KNIME. So on the KNIME forum, the common tasks that I saw were table recreation, topic modeling and labeling, and even target text analysis. So with table recreation, we might, for instance, have a text-based PDF, and it has a table within it. What I want to do is extract this table down here in order to perform analysis later on. As well, I might want to do topic modeling or topic labeling, where I just want to identify, for instance, what are the most common topics that come up in my PDFs. Or on the other side, I already know that I have 1,000 PDFs, and each of those PDFs is going to belong to a certain category. So what I want to do is scan the text, and then I want to label it belonging to the category. There's also target text analysis, where we will simply look through the text, and we're looking for instance, a date or an amount paid. And we know that there's a pattern in my data, but we don't always know where it will be in the data, but we know there's a format for it. So I can perform target text analysis, which we'll talk about later in the Regex section. So let's talk about table recreation and topic modeling and labeling. For table recreation, for instance, let's say that we want to analyze this weather data that comes from this PDF table. Now, this is a text-based PDF table, so I can put it through the Tika Parser. Now, unfortunately, what's going to happen is I'll have a single row and a single column, but I can't do any processing or any kind of data analysis with this. So what I need to do is break up each of the lines and each column. And eventually what I want is something that looks like this, where I have each column corresponding to the types of data and different rows. So how would I do that? So I will also link how we have solved this in different ways. But one way that I liked to do was to use the Tika Parser. I would get this output, and then I would use the cell splitter. So this is a single cell. And what I do is split by the new lines so that every single row then becomes its own row. Now, the cell splitter node takes advantage of the fact that the Tika Parser kept the formatting. So this is a case where I'm going to exploit the formatting. I can do a few more steps, and I can get 90% of the way here. So with just 5 nodes, I was able to get from an image or a table that was text-based into something that I can actually analyze. Now, we do have these community solutions, which are provided because we have Just KNIME challenges. And every week we put out a challenge like this, and we ask the community to solve it. And so you can see my solution here, and you can also see other people's solutions as well. Now, for topic modeling, this is a special subset in machine learning. And what we're trying to do here is discover unknown topics in our text. For instance, I'm reading the news and I notice that I have 1,000 PDF news articles, and I want to know what are the most common topics. I don't know this ahead of time. So I don't have any lists in order to provide my computer with in order to figure out, hey, which topics do these texts belong to? So what I can do is pre-process my data using some standard natural language processing nodes that KNIME has. And then I can use the topic extractor node. And this node will go through the text and say, I think these 2 or these 3 sentences belong to the same topic. And then I, as the human, can come in and look at this topic and say, oh, okay, I know what this topic is. For instance, here, I'm seeing that I have 3 different, let's say, PDFs. And in the PDFs, they have some topic sentences, something about meat, okay? Something about barbecue sauce, okay? And something about eggplants. So this has been assigned as topic 3 because it typically deals with food. So I can say, as the human in the loop, that this topic is probably about food. And so I can discover these unknown topics within my text using this workflow. And you can see examples for how to do this on the KNIME Hub as well. And it's very, very neat, and I've seen it used quite often. Now, the opposite case, though, is topic labeling. In topic labeling, I'm trying to categorize each row or each PDF with known labels. So let's say I'm an engineer, and I have 1,000 PDFs, and these PDFs are reports of the most common issues that happened. So I already know ahead of time that I'm going to be looking at reports that talk about cracks or material or vibration or missing or coding problems. So what I can do then is set up a workflow that labels each PDF, so that in the end, I have each row corresponding to a single PDF, and I've labeled it with a category. And this will help me later on figure out what are the most discussed issues. When I want to investigate a certain issue, how can I go ahead and filter only to, for instance, the cracked materials? And you can check out, again, community solutions, so not just my solution. And you can also see the KNIME forum discussion on this. Okay. Now we're on to the extracting patterns section, and this is going to be using Regex. And Regex is a little bit complex, so I will give a brief introduction to it and how it works. Okay, so Regex, or regular expressions, they are a set of special characters that can help us search through the text, replace the text, filter the text, split. We can do all kinds of things with Regex within KNIME. It's fantastic. But why are we using Regex? here we're looking for a certain pattern in our documents, like a date, for instance. But it's really time consuming to find these dates manually. Let's just think about this. I know that I'm going to have dates that span all of 2000 in, let's say, 1,000,000 PDFs. Do I want to start writing out, find January 1st, 2000, find January 2nd, 2000, find January 3rd, 2000, and then look for these in each PDF? I don't want to do that, right? Because that's 365 dates per PDF. Then you can imagine that some of the dates have a different format. Okay, so they have a different format now. So now I need to add 365 minimum, another set. Oh, but wait a minute. I'm not just looking at 2000. I'm also looking at 1990. I'm looking at 2010. Okay, so now you can see the combinatorics here are explosive. And so what we'll do is look for a certain pattern. So we'll say you're looking for a date. And what defines a date is going to be how we set up our regex. So let's look at some examples of things we might want to look for. For instance, I might find a date like this in one of my 1,000,000 PDFs. I'm looking through the PDFs to see if this is consistent, and I find another format. All right. I look again, I find another format. Okay, so this is going to get tougher, right? Because these are different formats. They're not even the same following. One of them is year, perhaps month, and then day, whereas the others might be a different format than that. Some use slashes, some use dashes, some use periods. So how can I make a pattern that can find this for me? That's what regex does. So regex at first looks a tiny bit cryptic, but once you understand these patterns in the same way that you recognize the alphabet, this can become very useful, especially for anyone who deals with text on a normal basis. So you have this date here, and we want to look for this specific structure or pattern. So we write this regex. We say bracket 0-9 bracket. This indicates any number. Then we say squiggly bracket and a 4. This indicates an occurrence 4 times. So literally find any number that appears 4 times, some sequence of numbers that appears 4 times. Then we separate the sequence by a dash, because here we have a dash. We do this again with the number. And then we see here squiggly brackets, but now we have a 1, 2. This means occurring 1 or 2 times, because of course, the month could be 1 or it could be 10. We don't know. So we specify that there's a possibility between 1 and 2 digits. We repeat this pattern and we're done. And so this regex pattern corresponds to finding dates like this. But is this enough to do 90%, 99, 95% of the work that we want to do in text preprocessing? Usually not. We're going to have to pick up just a few more regex alphabets or patterns. And so in my opinion, I think you only need these 5 to 7 patterns in order to get 90 to 95% of the work done that you'll need to do. So I don't think you have to learn regex in depth or be an expert to use it well. I think with just this set, we can actually get very far in our work. So I would like to introduce you to, for instance, the wildcard. You can see here the example F.R. And this will find us, for instance, for, and far because of this wildcard symbol. Even F, R, for instance, will be found. We can also have unknown quantities or repeated patterns. So for instance, a number that occurs some number of times, but I don't know how many. For instance, it could be 77, 2 digits, 9, 1 digit, or 1, 2, 3, 123, which is 3 digits. I don't know. So I'm going to say it repeats itself. When it stops repeating itself and becomes a space or a letter, don't count that. Then for letters, we can specify with that same structure of brackets and then A-Z. This is for uppercase letters, of course, because these are capitalized. So if we want to find any letter, we simply combine them. We say lowercase a-z, and we put it together. Then we can find any letter. Finally, our last 2 neat patterns that we use in regex are the OR expression. So find a pattern on the left or find a pattern on the right of this symbol, the bar symbol. So this is a 4-digit sequence or a 2-digit sequence. And then we have the capture groups. Capture groups allow us to say, find anything. Anything here is defined as the wildcard, and then the repeating pattern. So this is find anything, find a 4-digit sequence, find anything. And then I can specify, I only want to find things after the 4-digit sequence by specifying that last capture group. Or I can do it actually in the beginning, and I can say, find anything from the first capture group. And if you have any questions with regex, what I really recommend doing is just Googling your query and just adding the word regex. And this will typically give you a Stack Overflow page with many people probably answering the same question that you have. You can also see the full regex documentation here as well. So this is usually quite difficult for people to grasp at first. So I'd like to walk through just an example for now. So how do we capture dates or IDs in these sentences? For instance, here I have 12/4/2002 is separated by dashes. Over here, though, I have it separated by slashes. I also note that this is the beginning of the document or the PDF, and this is the end of the document or the PDF. Then for the IDs, for instance, I want to find capital D and then some string of numbers. But notice here there are 4 numbers, but over here there are 3 numbers. So I'm not always sure how many numbers this ID will have after it. And over here, I need to include regex that allows me to not worry about a dash or a slash. So what could I write? For instance, I could write either of these 2 patterns. I noticed there are hand raising. We will answer questions at the very end in a special Q&A session for 15 minutes. So please don't worry. You can go ahead and either write your write your question in the Q&A section, or you can keep your hand raised. And then when we get to the 15 minutes, you can go ahead and ask the question in the chat. Okay, so to solve this, there are 2 easy ways that I've come up with, but there are many ways to solve this problem because regex is an alphabet, and so we can come up with many solutions, just like you can in Python or in KNIME. So for this simple solution, I say, let's say a number occurring 2 times, and then the wildcard symbol. So it can find either the dash or the slash. Then a number, and then a wildcard, and then 4 numbers. And this is really specific to this use case, right? But say this is not really a 4, say this becomes a 10. Then this regex will break because I've specified specifically you can only find 1 number. So I can write a bit more vague regex or more inclusive regex like this. And so this is find any number of numbers separated by something, any number of numbers separated by something, and then any number of numbers. Now this regex, for instance, might also capture social security numbers. If there are no social security numbers in your document or PDF, it's not a problem. But if there are, then you're going to get some false positives. So this is the trade-off between writing very strict regex and writing more vague and open regex. For the IDs on the right-hand side, I can see here that I can say, let's just say a literal D that I'm looking for, not any alphabet letter, but the D letter. And then some number. And this can be some number with a 3 or 4 sequence. Or I can do something more open and I can say D and then some sequence. So either of these will capture what I'm looking for with respect to these 2 sentences. And I'll always have to be careful of false positives and false negatives when using regex. As well, I have various examples of regex in KNIME, which is a workflow that I constantly maintain and update, where you can go ahead and see how did I construct these, where are the use cases for them, what kind of data did I input in order to get what kind of output. So you will have access to this when we publish this video and the slides. But various examples of regex is available right now on KNIME if you want to look for it. Okay, so we are in our 3rd and final section, which is parsing unique languages with Python integrations in KNIME. So first, We want to talk about installing Python or getting the Python integration, because this is going to be the only, I think this is the part that people kind of think, oh, this is going to be tough, or I'm not sure how to do this. Well, actually, it's very simple. What we do is go to the KNIME Hub and we type in Python. Once we've typed it in, we check on extensions and we look for the Python integration. We drag and drop it into this, our KNIME Analytics platform. We follow the instructions, and that's it. Now we have Python installed, or rather the capability to use Python. So how do we specify Python? How do we specify our environment? We go to File and Preferences. Then we come down here and we're looking for Python. In this, we're allowed to specify the version of Python, whether that's version 2 or version 3. And we recommend setting up a Conda environment. Then down here, you can actually click New Environment if you're not sure how to do this, or you want to, for instance, create a deep learning environment, or you'd like to use a specific KNIME environment just for using your workflows. And any libraries or anything that's imported into those environments is then usable by KNIME. So let's actually look at that. So I have a workflow here, which is specifically meant for OCRing your text if you're working on a Mac. Now, the issue with the Test4j is that it only works on Windows. So that's why I wanted to create this, my own solution. And my own solution is possible because I'm using KNIME, which is free, and because it allows me to integrate with Python, for instance. So before I explain this workflow in general, let's actually look at the OCR node component, which contains the Python. Okay, so here I'm going to, before I explain this, jump right into the Python scripting node so that we have a sense of what I'm doing. Okay, so you can see here, I have very few lines of code. I think this is only about 10 or so lines of code. And what I've done is the usual things that we do in Python. We have imports. So I'm telling KNIME that, hey, I want to use pandas and NumPy for data preprocessing. I want to then transform my PDF into an image, because as we talked about earlier, we need to translate the image into text. And so I will use CV2 as well in order to do a little bit of image preprocessing. So if you have a particular difficult PDF and you just cannot get it to OCR correctly, you may have to add in some image preprocessing steps. So I've purposely shown a few examples for how we might do that. And then I added the PyTesseract library, which is going to be our OCR engine. But you can replace this engine with whatever engine you feel comfortable with, or maybe something even more state-of-the-art. Now, what you notice here is that on the left-hand side, I have my input variables, which are coming from my KNIME input, my tables from KNIME. I also have flow variables as well. Now, I say here that I have the input table and the file path. In order to grab this, I can actually come over here and double-click, and it automatically generates right here. Then I can also specify a popular path, which is useful for importing. It's going to help us with our transformations. Once I have my PDF transformed into an image, I can do things like write functions in KNIME, for instance. And I can say, hey, I want to grayscale this image, or I want to threshold this image. I want to make it sharper so that there's higher contrast between the light and the dark areas. Once I've done that, I can send it through my OCR engine, which is PyTesseract here, by simply calling a function. And then I can output. In KNIME, in order to output with Python, we have to send it to the pandas data frame format, because that is how KNIME reads and outputs. So you can see here, I'm going to output a data frame, which is going to have the text and the file path. And let's check that out. So you can see my output here. It has read in this Japanese text, and it is giving me the file output path. Okay, now let's talk more generally about what I did in this particular workflow. So first, I began with list files and folders. And what I wanted to do was read in images and text-based PDFs. I've had this problem before when I worked in a medical setting where they had thousands and thousands of PDFs. They had no idea which were the image-based and which were the text-based. They just had a folder. So I had to figure out a way to separate those. So what I decided to do after researching was, okay, I'm going to try an attempt to extract the text from all the PDFs. And what I noticed was that some PDFs, even if they were image-based, I was still able to extract some text. So I said, okay, I need to figure out, for instance, which PDFs have very few amounts of text and which PDFs have very high amounts of text. And then I can set some threshold. I can say, well, when I looked at the distribution of text versus image-based PDFs, I found that those with text had, 16,000 letters or words, and those without, well, really, they only had like less than 10. So I'm going to set that threshold. So what I do here is I'm going to split, and I'm going to say anything with less than 10 words or letters, I'm going to OCR that. But anything else, I'm going to say it's a text-based PDF, and I'm going to assume that I was able to extract the data. Of course, I'm always verify. So assume, but verify. Now, some other really cool things that we can do in KNIME is, as you saw, I was able to put nodes wrapped inside of a component. So I was able to bundle them. This makes my workflow much more efficient in terms of how it looks, easier to comprehend, easier to read. As well, when I put all the nodes together, I can actually do special things like set up a user interface. So I double-clicked on the OCR node. Now I have a user interface. So I can have you go ahead and give me your popular path, which is a library we needed, and your Tesseract path, which is also a library that we needed. You can then also specify the language that you want to do. And I did all this using just a few nodes. And these nodes in particular were the string configuration node and a single selection configuration. Then whatever the user selects, I'm able to pass to my Python script. As well, notice I have loops. This is another cool thing with KNIME, right? You don't expect this from a visual language, but we have loops. We even have try and except. In KNIME, this is called try and catch. So I can say, send in one PDF at a time into my Python script and run it, then extract the text and move on. But if I get any errors or maybe a corrupted PDF or something that I'm not expecting, I can actually ignore that for now and come back later to fix it. So this was an example of how we can integrate Python and KNIME together. And I do want to talk a little bit more about setting the threshold to determine if we have image-based, but I feel like there's a lot of questions. So I'll stop here, and depending on how quickly we can go through the questions, we'll come back to this. So let's see how we look in the chat so far. Okay, let's see. When using the OCR node, will the orientation of the text on the image be important? Yes. For instance, if you have slanted text, some OCR engines can correct this and move it back into a perfectly vertical or 90-degree alignment, but not all engines will do that. Another thing to consider is that if you are using, so for instance, we're looking at Chinese or Japanese text, this text can be a vertical or horizontal, right? Because Japanese, you can write down or you can write across. And with that, some OCR engines automatically detect the differences for us. And so in that case, like for here, I actually have a combination of text that goes down and text that goes across. And I find that the OCR engine automatically figures out which is better. Okay, the next question. What level does the test4j node perform OCR? What level? Sorry, Melissa, could you perhaps give me a little bit more context on what do you mean by the level that the test4j node performs OCR? And then I'll come back to that. It'll be in it'll probably pop back up in the Q&A section. Okay. Could you also touch upon the PDF file creation date extraction? PDF file creation date extraction. It doesn't always work with a Tika Parser and HTTP result extraction. Are there any workarounds? PDF file creation date extraction. I see. So you're saying that when you use the Tika parser and you specifically said, hey, please extract the date that it was created, it doesn't always give you the correct date, right? So in that case, what I'd like to do is please go to the, I believe Shantanu has posted it, but there is a KNIME forum thread specifically for this webinar. And what I'd like to do is if you can show me an example of a PDF that doesn't work like that, and then we can walk through that example and I can answer it on that thread, because typically I would need to see the PDF and see if the PDF is what's causing the issue or not. Okay, do we have a node to choose the region of the PDF or image to be run by OCR, improving the results? Ah, I see. So I think we're talking about here is bounding boxes. And at the moment, we don't have anything in KNIME that does anything so sophisticated. And that is, bounding boxes are really, in my opinion, state-of-the-art work. And they still have more work to be done on them. But I think these are separate libraries that you may be able to find with a Python integration and put into KNIME. But at the moment, no, we do not have such a feature. Okay, what if the regex ID in ID has multiple letters apart from D? Yes. So you remember the brackets that we used earlier? So bracket 0-9 or bracket A-Z. You can actually use those brackets to contain letters. So you can say A, D, Z within brackets, and then you can do the numbers that come after it. And so this way will allow the regex to say, okay, I'm looking for letters, but I don't know which letters, but I do know that it's one of these 3 letters instead of saying the whole alphabet, for instance. So if you have this kind of example that you want to share or show, you can either, actually, I would really love if you put that in the KNIME forum thread for this webinar so that I can show you exactly how to answer or how to deal with this problem. Okay, is it possible to use regex flag modifiers in string manipulation regex matcher? I think we do have the ability to use some flags and modifiers. You can check out the various examples of regex. Just type in various examples of regex KNIME into your Google search, and this should be the first hit that you get. And in there, I know that I've used some modifiers or flags. For instance, ignore capital letters, rather ignore capitalizations. So you should see examples of that in that specific workflow. But if you don't, and you'd like to ask more questions, please ask us on the forum. Okay, ergo multiple line /m or case insensitive / yes, exactly. So I have used case insensitivity before, definitely. I'm not sure if it's exactly the node that you talked about, but I have used it before in a node with regex. Okay, next one. Is it possible to turn Victor's Python script node into a Python component in 4.6? Ah, thank you so much for asking this question. So we are actually really excited to try out, instead of having this as a script, turn into a component in 4.6. So that will be actually our next task. We actually want to focus on creating our own kind of PDF software that people can use and modify as they see fit, using this Python components later on to come in 4.6. So thank you. We will definitely be working on that. Okay, can you share this workflow to the website, please? Yes, absolutely. So all of these workflows, as well as links to everything that I mentioned, will be posted as soon as we post the video. And I believe this will be posted on the KNIME forum as links, but if not, we will also post it on the official page that we had. Okay. How to extract text in text boxes inserted in pages? How about detecting handwritten annotations? Are these possible? So certain OCR engines, which for instance have a deep learning backend engine, can do handwritten. And I've seen that over the course of time, these have gotten better and better and better in order to detect the handwritten notes. For test4j, I have never used a handwritten with the test4j node, so that would be really interesting. If you can post, for instance, something like this, we can try to see whether the Python script that I wrote, or if you have a Windows computer, I don't, unfortunately, but if you have a Windows computer, you can also test it there as well. And then extract text in text boxes inserted in pages. That one I'm not sure about. I would like to see an example for what you mean by that. If you can put it on the KNIME forum, that would be great. Okay, so test4j won't work on workflows executed in Linux-based KNIME server. So unfortunately, I cannot comment on that because I have not tried it myself. For this one, I would say, again, please post to the KNIME forum for this webinar. And then in that webinar, we can see if we can get to talk to some engineers and see how the test4j node operates on these Linux-based KNIME server instances. A question, is this session recorded? Yes, it's recorded, and we will have our recordings out probably by the end of the week. Okay. You mentioned that OCR can be done at this character, word, and content level. What level does the test4j read the images? I believe it is character and word level. I don't think it goes so far as to read the content level, which is more of a deep learning. From what I've seen, it's more of a deep learning task. And so that is also one of the motivations that I had for creating this Python script, so that people can feel free to change out the engines and see, for instance, okay, the test4j node, which is based on Tesseract, that didn't work out so well. Let me try a different engine. Okay, so invoice numbers are often written at different points in relation to the words invoice number on a PDF. Is there any advice you can give on how to get invoice numbers out of a batch of different invoices? Yes, so we're saying that at different points in relation to the words invoice number, we'll be able to find them. So most likely what's going to happen here is you're going to see invoice number, and it's going to appear, for instance, on the right-hand side. Sometimes it'll appear underneath it. And depending on how it's structured, for instance, like if it appears underneath it and it's appearing by a line break, you might use, for instance, the PDF parser, which will extract all the formatting. Then it will force this to be on a single line. Then you can say, okay, I have the invoice number. I need to find this one. So my target text analysis, I'm going to find invoice number. Then what I'm going to say is I'm going to have a window that comes after. And the window is going to be, let's say, 20 characters long. So I'm going to find invoice number first. Then I'm going to find some window of 20 characters. And then I'm going to extract that. I extract this, and then I can perform some easy sub-analysis where I say, okay, find me a series of numbers from this 20-character string that I extracted. So I've actually done this before when I was extracting medical record numbers from patient data. So from there, we extract what they're called MRNs, and then there's a number that follows it. And so I always look for MRN. Once I found that, I then said, find me the next 20 to 30 characters. And then from there, I made my regex work specifically on that. So if you have an example of this and you'd like to share it with us, please do so on the KNIME forum, and I can actually show you a little bit more in depth how that was done. Okay. Let's see here. In simple terms, for a low-code user like me, can I write some OCR scripts using Python to perform the PDF text conversion first, then turn it into a node in KNIME, like what's being shown in KNIME? And are there any special requirements for such Python scripts to ensure a smooth integration in KNIME? Yes, so I've actually done both. I've written a image-based PDF extraction, which you see here in the OCR node. But you can actually do a text-based extraction as well if you choose to in KNIME. Now, if you are a low-code user, I assume this means you do have some Python experience. So it simply means that you will need to download the libraries that you have or that you would like to use in your Python environment. Then from there, once you connect them, you can look at the slides for how to make that connection between Python and KNIME. And then you can go ahead and write whatever you'd like to. So let's see here, OCR, and I'm going to go inside this component. And then you see here I have the Python script. So there are actually several nodes for Python-based, and some of them don't even require input. So you can actually begin all your work using Python and then move on in the KNIME nodes. And if that is not clear or you need more clarification, please remember to write in that forum for us. Okay, I know you covered this in the text-based PDF analysis, but say we deal with a lot of vendor invoices, which are text-based PDFs that have header level information, i.e. ship to bill to, and then line level information, the product purchase, the units, the quantities, high level. What is the best approach for this? Test4j, Tesseract, Python, Amazon, OCR. Okay, so if you're dealing with a text-based PDF, you can use KNIME's either the Tika Parser node or the PDF parser node. And then what you can do is check whether or not, for instance, if this is vendor data and you have these header level and line level, what I'm guessing is that you can exploit the fact that there are new lines, that there are line breaks, same thing, that there are spaces and things like that. And so what you would benefit from, let me see here, is the table extraction. So in your case, I would say use the Tika Parser. And the Tika Parser will give you information like this, and it will contain the format that you're looking at. So you can see here the format. And we notice there's line breaks. And so what I did was I took advantage of these line breaks. And to do that, I used the cell splitter node. With the cell splitter node, I said break all of my rows by the new line, the /n. Then what happened, I had several different lines with each different piece of information. So for your case, for instance, it might be the ship to bill, or it might be the products purchased, the units, etc. Then I transposed it so that it looks now like the original file that I had. So now you can see this looks like the original file, but I have some more issues, right? This is still a single column. So I need to then use a cell splitter again and split by spaces. So I think you might be able to perform the same thing. And so you would have the left-hand side being the column, which would be, for instance, the ship to bill to, or the units. And on the right-hand side, it might actually have the units for you. So you can play around. I recommend this one, the PDF table extraction, which is actually on the KNIME Hub right now, if you'd like to go check it out immediately. Or you can wait for these slides to come out, and then you can click and see how I solved it, and also how community members solve a similar problem. Okay. So live done. Okay, is it possible to remove headers and footers from the PDF text? They're often disturbing. So if the headers and the footers both contain some signature, or they both follow some very specific pattern, then you can use regex to replace those with nothing, or with a blank space, for instance. So oftentimes people will use regex replace, and they will remove sensitive information. And I have an example of this. If you go to various examples of regex in KNIME, the workflow that I've built out, you can either type that into Google, or you can wait for the slides to come out, and you can see different ways that you might tackle this problem of getting rid of the headers and the footers from the PDF. IG at page breaks. Yeah, exactly. Okay, PDFs have metadata in XML. Can we extract info from the XML metadata? Okay, and I noticed someone has raised their hand. In this particular webinar, you're not allowed to chat. We did that so that there wouldn't be any interruptions in terms of noise. So please type your question to me, and I will answer it in the order that I receive it. Okay, so PDFs have metadata in XML. Can we extract info from the XML metadata? Yes, there are specific nodes in KNIME that deal with XML files. I believe, let's see here. I believe either Rosaria or Shantanu are on the chat. They should be able to tell you the exact node that deals with XML metadata, but it is perfectly possible to extract your data that way. And if you cannot find the node that you're looking for, post it on the forum and I will answer it. Okay, does the Test4j perform properly for any language, or is it more English oriented? If we have foreign characters, i.e. Japanese kanji, would it work with Test4j? If not, what would you recommend? Okay, so the Test4j node at the moment is limited to the libraries, language packages that were installed onto it. And the test4j node, I think, only contains more, how do I say this, alphabetic character-based items. So you cannot at the moment choose Japanese or Arabic, for instance. And this is also another reason that I wanted my own solution, so that I could allow people to choose what language they wanted and what language package they want. So you can actually find OCR Python. You can find this on KNIME Hub right now, and you can download it and play with it. And it works immediately with Japanese. But if you want to say do Chinese or Arabic or something, you'll need to simply install those languages into your computer, and then tell KNIME, for instance, here you can see OCR when I double click it, tell KNIME by directing it to the Tesseract path. And inside of the Tesseract path, you will find the language packages. So I would recommend using this workflow if you're dealing with Japanese characters and you need to do OCR. But if you don't need to do OCR, you simply need to do a text-based PDF extraction. You don't need to use any special packages. You can simply use the Tika Parser or the PDF parser, and it will extract any language. Are there special requirements for XFA-based PDF extractions? If so, what would they be? So I'm not sure what XFA-based PDFs are. So if you can show an example of that, or maybe give a link in the forum for this question, that would be great. I think I can follow up on it there, but I personally have not seen those before. Okay, yeah, so we are now at the 4-minute mark before the end of the discussion. So let's see here. Okay, and it looks like all the questions have been answered. All right, so we do have 4 minutes. So I think what I'll do is kind of look at topic labeling. So I earlier mentioned that you might have several PDFs or several text items. And these text items, for instance, have parts inspected and I found cracks. And you're putting on your engineer hat, and you want to find out what are my biggest issues. So which items come up the most? So I know right away that I'm going to have issues with some, for instance, materials and cracks and some other items. So what I can do is create a list of topics. I can say, I'm going to find cracks, materials, missing, dent, etc. I know these are going to be inside of my text. I can then make them all together on a single line by using a concatenate function of the group by node. So this will transform that table that we saw into a regex statement. And this regex statement is simple. It's crack, or material, or missing, etc. So now that I have that regex statement written out for me, I'm going to pass this as a variable to regex find all. Regex find all is a community-made node, or component, should I say, and it allows us to type in some regular expression and find every instance of that word being used in our documents. So I'm going to say finding is my target column, and here is the input that I originally used, but actually I'm going to be using the string or the flow variable from above. I'm going to use this string that I showed you earlier here. Now the output from this is going to show me when a certain keyword appeared in any of my PDFs. In other words, I have now labeled all of my PDFs. So I know that this is a crack, I know that this is crack, I know this material, and that would help me then analyze further downstream, what are the main sources of errors for my PDFs? Then you noticed here though, that the output kind of came in this format with brackets on it. We don't want that because that is a collection. So we want to split the collection. So we come here to do split collection. And now you see I have 2 different columns. So then I could do this and I could perform some kind of count and just check, of all these PDFs that I have, the number 1 reported issue is cracks. So that's what I need to fix first as an engineer. Okay, so we are at the 1-minute mark and I do not see any more questions. So I am going to leave it here, and I'll just, if anyone has a last-minute question, go right ahead. Otherwise, we can end here. And thank you so much for your participation. I'm glad that we have this recorded and it will go out as well as the slides, so you'll have access to everything.